Couple of remarks. For line integrals with respect to arc length, this is really important. The orientation of C doesn't matter. So if you want to compute the line integral of f along C, it's the same as the line integral of f along minus C, where when I write minus C, I mean the same curve but with the opposite orientation. So for line integrals with respect to arc length, orientation doesn't matter. Now it's really important that we realize that it will matter for all other kinds of arc lengths, actually, but for line integrals it will matter for all other kinds of line integrals, but for line integrals with respect to arc length, the orientation doesn't matter. Second, if your curve C, if you can write your curve C as the sum or union, however you want to think about it, as a bunch of other curves, you can break it up into these pieces where each piece is piecewise well-behaved, is piecewise smooth. So yeah, there's cusps here, but I can think about it as this curve and then this curve and this curve, so on and so forth. Then the line integral of f along C behaves really nicely. You can actually break it up and add up the line integral of f along C1 plus the integral of f along C2, so on and so forth. I won't read all the way through it. You got the idea. So those are two important facts to be aware of. So next, I want to show you two other kinds of line integrals. So you can have the line integral along C no longer with respect to arc length, but with respect to x, and the line integral along C with respect to y. And these integrals do not have the same interpretation as area. You can interpret them as an aspect of what we're going to see later, work. So there's going to be a way to view a different kind of line integral as the work of moving a particle, and these integrals with respect to x and y, you can think about it as having to do with that, although they in and of themselves don't have necessarily physical interpretation. They're still really important. So how do we define the line integral along C with respect to x? Well, we write it like this. Same symbols, I don't put ds, I put dx there. And when it comes into computing it, it's the integral from a to b of f of r of t times x prime of t dt. I'm assuming my C is parameterized by some r of t for t between a and b. I didn't write that down. Similarly, the line integral along y with respect to y, you're going to write like this, and you're going to get the integral from a to b f of r of t times y prime of t dt. That's the line integral along C with respect to y. So a couple of comments. Orientation absolutely does matter for line integrals with respect to x and y. If we had a little more time, I'll draw a picture and show you, but for now, just take my word. What happens if you look at the integral of C going in the opposite orientation, so minus C, it's just the opposite sign of the integral of f along C in the regular orientation. And again, orientation is all a matter of context here. So whatever you start out with is your starting orientation. If you go the other way, then you're just going to change the sign of the integral. So it's not a big deal. It's not hard to deal with the different orientation, but it's really important that we keep track of it and don't forget about it. Let's look at one other kind of notational issue. So a lot of times the line integral of a function along C with respect to x and the line integral of a different function along C with respect to y, a lot of times these are going to occur together just like this. We're going to care about adding them up. I'll show you why at the end of this lecture series. So it's common notation to save a little bit of writing and only write one integral symbol. Now it's kind of weird, but when you see this and you see a function dx plus a function dy, all that means is the line integral of f dx plus the line integral of g dy. So just be aware of that. These often occur together. And like I said, towards the end of this video series, we'll take a moment and see what's going on. So I think we'll stop the video here and we'll do an example in the next one.